Hey there, everybody, welcome back. No, I've not even started grading you guys' tests. I'm grading Top Q's test. With 2 tests in 1 week, it's a bitch. But most of you know pretty well how you did, at least on half of it. Because you know whether or not you got the unit circle right or not. That was half the damn test. So like, that last test should be one of the easiest ones to pass. 7.1, we're doing 2 sections today. Let's talk about what chapter 7 is in general. This is math 54. Chapter 7 is on trigonometric identities and equations. And 7.1 is on the fundamental identities. So we reserve the word identity in math for a special kind of thing. Identities in math are equations that are satisfied by every single value in their domain. It's something that's always trivial. We've covered some of them already, the reciprocal identities. Some of this is going to be a rehash or a reminder of what we've had. Cotangent theta is 1 over tangent theta. And that's the same thing as tangent theta is 1 over cotangent theta. We have our secant and cosecant. Secant theta is 1 over cosine theta. And cosine theta is 1 over sine theta. Not 1 over sine theta, 1 over secant theta. And now our cosecant and its relationship to sine, they are reciprocals. Apparently, I am writing out an angle here. How awkward. Quotient identities. Tangent is sine over cosine. And cotangent is cosine over sine. These are ones you know. Our Pythagorean identities. Start with sine squared plus cosine squared equals 1. And then divide both sides. Divide by sine squared. And you get 1 plus cotangent squared. Theta equals cosecant squared theta. And if we divide it by cosine squared, you get tangent squared theta plus 1 equals secant squared theta. So those are the Pythagorean identities. We're just getting them all down on one page, and hopefully these all so far look familiar. We've used the sine squared plus cosine squared equals 1, right? Have we done that in here? When you're teaching a shitload of math, it really help orders. But you guys would know. Jordan's not in your head, but that doesn't mean anything. Does anyone else recognize sine squared theta plus cosine squared theta?
Yeah, I remember using Pythagorean theorem.
Okay. It stems from x squared plus y squared equals r squared. And I'll just walk through that real quick. Actually, I'm gonna walk through that on the next page, because. Actually, let me walk through that in a second. Let me get the other identities on this page, that way we only have one page of identities. Even odd identities real quick, and then we'll walk through. How you get the Pythagorean identities. Sine of negative theta is negative sine theta. It's odd. And that means cosecant's in the same boat. Tangent and cotangent are also odd. Finally, cosine of negative theta is cosine of theta. And secant of negative theta is the same thing as secant of theta. So these are the even ones. These ones are the odd ones. Odd means you can plug in a negative value or negative variable. The opposite sign of variable, and it just changes the overall value. You plug in negative x, you get negative f of x. Even if you plug in negative x, you just get f of x. Give you a chance to finish writing those down. We'll walk through x squared plus y squared. Pythagorean identities again real quick. I'll be honest, the even and odd identities really only help speed things up later on. I don't know that they're all that useful right now. They, at least in trig, they, even in odd things, when you do calculus and even higher. As you're going down the stem branch kind of deep, the properties of even and odd make things easier. But. Doesn't really do a lot for you now. So much shit. More people are still writing. 7.1 is a short section. 7.2 is gonna be. Probably the section you hate maybe the most in this entire fucking book. Maybe. What? You'll see. It's today. Why it requires you to think. Not just memorize and do basic shit, you're gonna have to think and you're gonna struggle. And students, well, not students, no one likes struggling. Despite struggling and being one of the major things that cause growth. When you're struggling on your homework and you finally get it, you gain a lot. If you don't struggle, you just straight go to looking up how it's done on, you're not growing. The fight is what makes you stronger. It's true in the gym. And then on physical things. There's no shortcut in some stuff, sometimes you just gotta struggle through it. Alright, so. Are you in a circle? I'm not gonna be able to go and write down the values again, well, not even in a circle, just a circle, radius r. This point right here has got the coordinate x, y. Which means if I make a nice little triangle, bring a line down. This is x, this is y, and that's theta. So what is cosine theta's value here? With unknown values on the circle, we just gotta use the variables. It's adjacent over hypotenuse, or x over r. Sine theta is opposite over hypotenuse, which would be y over r. So if we multiply both sides by r, we're gonna get x equals r times cosine theta. And y equals r times sine theta. And if we drop these into x squared plus y squared equals r squared, which is the Pythagorean formula for this triangle. We're gonna plop that sumbitch in there, we're gonna plop that sumbitch in there. This will be r cosine theta squared plus r sine theta squared equals r squared. I don't think I've done this semester. I may have said the formula, but I don't think I've gone through where it comes from and stuff, so this is worth doing. And square hits everything inside, so this is r squared cosine squared theta. And this is r squared sine squared theta. Equals r squared. Let's pause there and make sure everybody gets to that point. Alright, we're almost there. We have R squared on both sides. Can we divide both sides by it? To clear it? If so. Why? Take a shot, Davis.
R squared out. R squared. Cosine sine.
But is that a legal operation? We can only divide by something if we know it's not gonna equal 0. Cause you can't divide by 0.
Right.
Is there any reason to think this can equal 0?
No, because then you would have a circle.
If it does, we don't have a circle, and this is a fucking 0 squared plus 0 squared equals 0 squared. So like R does not equal 0, so we can do that, we're gonna divide both sides by R squared. And we get cosine squared theta plus sine squared theta equals 1. And for some reason, we often write it with sine squared first, I don't know why. But these are interchangeable. So whichever way you like to memorize it. Memorize that one. The derivation, I said we could do it on the other ones. And I'm gonna rewrite this equation twice. If we divide everything by sine squared. This one, sine squared divided by sine squared is 1. Cosine divided by sine is cotangent, and that's squared. So cotangent squared. And 1 over sine squared is using that reciprocal identity is cosecant squared. So that's one of the other identities. And if we do it by cosine squared instead. Sine over cosine is tangent. Cosine over cosine is 1, and 1 over cosine is secant. So we have that one, and that one, and that's the derivation. I could have gone straight with the unit circle R equals 1 and bypass this whole R squared thing. But I wanted to make sure you know this holds true for every circle, not just the unit circle. Okay, so, and this happens a lot. We will also use these variants. If I take sine squared and subtract it from both sides. I get cosine squared theta equals 1 minus sine squared theta. Or I could subtract cosine squared theta. And I get 1 minus cosine squared theta. This happens a lot, especially as we're going through calculus and stuff. Being able to switch between different trig functions by using identities is really helpful. And we're gonna use it in 7.2, some of this stuff. Alright, the next bit, we already have other ways to do, but we're gonna do some of this stuff using these identities. Does anyone need this up longer? I don't know if you're actually writing notes or like. Copy what I'm doing or making notes to yourself. Okay. So like, let's say cosine theta, to an example. Cosine theta is 5/8. And theta is in quadrant 4. Find the following function values. Sine theta. That might help you to draw a picture. Quadrant 4 is this one. Which means. The real theta is doing this. But. Our equivalent theta. That has another name. I'm brain farting on what I call that. We can use that, and so. That's what we're looking at. Now, in the past, we have gone and done this with a triangle and said cosine. This is not the way we're gonna do it. But cosine theta is adjacent over hypotenuse. So adjacent would be 5, 8 would be this is y. And we could calculate y and then fill in all the other things, we've done that in the past. Instead, we're not gonna use that, we're gonna use the identities that we just had. So if I have cosine theta and I wanna find sine theta. The idea is to look through the identities we had and go, do any of them have both sine and cosine in them? And just sine and cosine. And it turns out the one we just got done proving. Sine squared theta plus cosine squared theta has both, and that's it. So we will dump cosine theta in there. So we're gonna have 5/8 squared. And that is 25/64. So I'm gonna write the 1 as a 64/64. Because I can see that I'm trying to get sine theta by itself. Figure out its value. So if I subtract that over, subtract 25/64 from both sides. I get sine squared theta equals. 64 minus 25 is 39 on top. And then we'll take the square root of both sides. We get sine theta equals. Square root of 39, which doesn't have a perfect root, over the square root of 64, which is 8. Sine theta is normally plus or minus, or the square root is plus or minus. But in quadrant 4, only the negative one is applicable. So this is from taking square root, plus or minus from square root. But only the negative one's applicable here. And that's sine theta. So sine theta is negative square root of 39/8. Which means if we had gone through and done this the regular way, this would have been negative square root of 39. Now, if we want to find tangent theta. Well, tangent theta is sine theta over cosine theta. We're going to use the quotient identity. And we have both of those. Sine theta was negative square root of 39/8. Cosine theta was 5/8. And dividing by a fraction is the same thing as multiplying by the reciprocal. You remember that from algebra? Our 8's cancel, so tangent theta is negative square root of 39/5. And just to throw in that even and odd shit, let's take a look at secant of negative theta. That's the same thing, secant was an odd function, or even function. So that's the same thing as secant theta. And secant theta, we can use the reciprocal relationship. And that is 1/5/8. We had cosine already. So multiply top and bottom by 8/5. Keep fucking doing that. We end up with 8/5. Those cancel, get 8/5. And why that is happening. We went around like that to get theta. Oh my god, what is fucking theta heck? It's got a name. It's fucking driving me crazy. It's not complementary. Complementary is 180 minus it. They had a name, fuck, it's bothering me. Alright, but if we did negative theta is going backwards that amount. So here our theta hat is that. And that's why, and if we're looking at secant. Both secant and cosine are positive here. Are positive in Q1 and Q4. And so that's why, because they're the x over r. Cosine theta is x over r and x is positive on the right side. So it's always positive, both of those are positive. And that's why plugging in negative theta is the same thing as doing regular theta. Not the most exciting thing, but it works. Reference angle. It was pissing me off, I had to look it up. It's the reference angle. Oh my god. You know, when the name is just eluding you and you know it. Alright. Some stuff we're gonna need for the next section is practicing doing some of this stuff. So in this example, let's write. Tangent theta in terms of. In terms of cosine theta only. Only cosine theta. So let's come over here and look at what we got. Things that have tangent in them. We have tangent theta is sine over cosine. That sign looks like it's gonna be a problem, so that one may not help. And the only other real identity we have is tangent squared theta plus 1. Equals secant squared theta. Well, this one, secant squared theta is 1 over cosine squared theta, so I think we can work with this one. Let's work with that, let's make that change. Tangent squared theta plus 1 equals 1 over cosine squared theta. And if I subtract 1 over. Minus 1 on both sides. I'm gonna write this minus 1 on the right side as minus cosine squared theta over cosine squared theta. So I get a common denominator. Is everyone okay with that? So now we're looking at tangent squared theta. Equals. 1 minus cosine squared theta. Over cosine squared theta. And finally, we'll take the square root of both sides. And I'm gonna do square root of top and bottom separately over here. So on the left side, we get tangent theta. Right side, we're gonna have a plus or minus, we're doing the square root, so there's a plus or minus in play. Top part, we wanna leave it in terms of cosine, so we're gonna leave that alone. With the square root of the bottom, square root of cosine squared is just cosine theta. Oh. Not squared. Let's take the square root. Any questions on that? I don't know if you were in here, David, it was reference angle.
What's for, I heard it on the way out. It's like,
So here we looked at the identities we had and only one of them. Could be written with just tangent and cosine. So we took advantage of that and went from there. Let's do another example that's kind of crazy. Let's write. 1 plus. Tangent squared theta over 1 minus secant squared theta. In terms of sine and cosine only. This is a useful skill. Not just in this class, but in calculus and stuff. So we'll start off. Tangent is sine over cosine. So this will be sine squared theta over cosine squared theta. secant is 1 over cosine, so this will be 1 over cosine squared theta. Now, complex fractions suck ass, that is my official position. So we've got cosine squared thetas on top and bottom. Let's multiply top and bottom by cosine squared theta. And you may want to put this shit in parentheses. That way you remember you need to distribute to both of them. It's really easy to forget. If I do it to the ones. On top and bottom, I'll have cosine squared theta for both ones. On the sine squared theta over cosine squared theta, the cosine squared thetas will cancel out. And on this one, the cosine squared theta cancels out, we're left with -1. Now, we are technically. In terms of cosine and sine, like I asked. But. We have to simplify, you should always simplify. Can I do anything here to simplify?
Cosine squares can cancel out.
No, that is an illegal operation. If you can only do that if everything is multiplied together. If there's a plus or a minus, I'm really glad you said this, because someone is gonna do this, and I bet a lot of people are gonna do this. We cannot just cross off cosine squareds, you can only do that when they're multiplied together. And with the plus or minus, anytime you see a plus or minus in there, that shit's out the window, you can't just cancel top and bottom. Unless you can cancel it from everything that's got a plus or minus between. Have we seen the top anywhere before? Wasn't this one of our identities? So, for now, we've got this down to 1 over cosine squared theta -1. And if we look at that cosine squared theta plus sine squared theta equals 1. If I subtracted 1 from both sides. I would have cosine squared theta -1. Which matches the bottom. If I subtract sine squared theta from both sides, I can have something that it equals. So I could rewrite this as 1 over negative sine squared theta. Which is a nice simple, like cleans a whole lot up from that. That is probably the simplest form in terms of. Sines and cosines. If you needed it for something else, you can see this is the same thing as negative cosecant squared. But that's not what I asked in terms of sines and cosines. And make sure you are writing these parentheses, put the parentheses angle in every time. Skimming through the test, people were just writing sines and cosines and not having an angle in there. And I promise you that is gonna fuck you hard when you take calculus. Cause having that in there matters, you're gonna change letters and variables. If you don't have, you're not following what's going on, you're gonna get the wrong answer. You need that, and it's part of the thing, it's the angle. Having a trig function without an angle is. Like fucking having salt with or pepper without salt, the hell is this? Alright, let's take a 10-minute break, we'll do the fun shit, 7.2 in a second. What you're all waiting for. But thick as you all, pay attention. Alright, 7.2. Oh, you know what? Let's make these two videos. Let's do stop